Hey everybody, this is Mr. W. Our topic today is comparing expressions in an equation. Compare the expressions, write equal or not equal to make the number sentence true. What I have here are two expressions. 5 plus 5, which you see on the left side of the page here, is called an expression. On the right side of the page, 18 subtract 5 is also called an expression. An expression is in math is when you have a combination of numbers and symbols to represent a value. My job here is to compare 5 plus 5, which is on the left side of the page, to 18 subtract 5 on the right, and then to put either the equal symbol or the not equal symbol here in the middle. I'm going to start with the expression on the left. 5 plus 5 I know is equal to 10. On the right, 18 subtract 5, if I work through that, would equal 13. Compare means that I put them side by side, and in this case, my directions are to use equal or not. Well, I can see that 10 on the left is not equal to 13 on the right, so the correct symbol would be the not equal symbol, but actually it would go up here. So we would say that 5 plus 5 is not equal to 18 minus 5. This lesson has some vocabulary. Compare just means to put side by side, usually on the left and right of a piece of paper or a screen. For example, 2 is placed alongside of 3, and I'm comparing them. In this case, I would say that 2 and 3 are not equal. So that's what we mean by compare. Expression, we explained, are numbers and symbols that show the value of something. Here's some examples. 3 plus 6 is an expression. 8 minus 2 is an expression. 4 times 5. 10 divided by 2. So notice that we can add, subtract, multiply, or divide. Also notice that there is no equal symbol. These are referred to as expressions. Equations do have an equal symbol, and we'll get into that in just a second. An equation, just a simple definition, is whatever is on the left side of your page or your screen is equal to whatever is on the right. So you have this idea of left and right. Left must equal right. And remember that an equation must have an equal symbol. We said up here that an expression, notice that there are no equal symbols here, but equations do have equal symbols. I'm going to show you some examples on the next page. Here are some examples of equations. 2 plus 2 equals 4 is an equation. Does it have an equal symbol? Yes. Does the value of the numbers, in this case the expression 2 plus 2 on the left, does that equal 4? And the answer to that question is yes. Remember, left must equal right to be an equation. Another example, 6 on the left is equal to 10 minus 4 on the right. If I were to do 10 minus 4, that equals 6. Well, that is equal to the 6 here. 5 times 3 on the left is equal to 15 on the right. So this is also called an equation. 2 times 3 equals 11 minus 5. I can prove that by 2 times 3, which is our expression on the left, is equal to 6. On the right side, our expression 11 minus 5 is also equal. And so you can see why this is another example of an equation. Keep in mind our symbols. This is the equal symbol. For example, 4 plus 3 equals 7 in an equation. The not equal symbol has that line going through. For example, 4 plus 3 is not equal to 10. I can prove that by adding this expression. 4 plus 3, that would be 7. And this is 10. And 7 and 10 are not equal. In other words, 7 here on the left is not equal to 10 here on the right. Compare the expressions, write equal or not equal to make the number sentence true. Let's try some easy ones. On the left, 20 divided by 5, and we're comparing that to the right, 25 minus 5. 20 divided by 5, and remember from previous lessons, you could use a multiplication table. I'm not going to take too much time with that because I'm not teaching multiplication today, but you can see that 1, 2, 3, 4. So 20 divided by 5, this expression would be equal to 4. 25 minus 5, that would be 20. When I compare left and right, they are not equal. So we would say that 20 divided by 5 is not equal to 25 minus 5. Our second example in the easy category, 6 plus 3 on the left, and we're comparing it to 15 minus 6 on the right side. 6 plus 3 would be 9. 15 minus 6 is also, notice the left and the right are equal. So in this case, we would put the equal symbol. Example 3, on the left, 13 plus 7. That would be equal to 20. On the right, notice I have 3 numbers, 23 plus 0 minus 3. I'm going to start with the 23 plus 0. That would equal 23, but then I have to subtract the 3. 23 minus 3 would be equal to 20. So I'm just going to slide that 20 down here. You can see that 20 on the left is equal to 20 on the right, so that's equal. Last easy one, number 4, 8 plus 4, that would be 12. On the right, 2 times 9 is 18. When I compare left and right, they are not equal, so I would use my not equal sign. Compare the expressions. These again are expressions. Write equal or not equal to make the number sentence true. These are middle problems, so I'll draw my middle face. On the left, 48 plus 17 plus 12, and we're comparing that to the right, the expression on the right, 12 plus 27 plus 48. Using the associative property, I could just add these. However, I notice here that I have 48 on the left. I also see 48 here on the right. So that so far would be equal. 17 here on the left, but I do not see 17 here. I see 12 on both the left and the right, but the 17, which is our third addend here, is not equal. So these would not be equal. You could also add all three and write your sum. But again, in this case, you could use that strategy. Another example of a middle difficulty problem. What number makes this number sentence true? Notice our expression on the left, 7 plus 13 plus 4, and then the expression on the right is missing a number, 7 plus blank plus 4. Our job is to figure out which of these numbers would go in here to make this true. We could add this, but because of the associative property, I can also just compare left and right. For example, I see 7 on the left. I also see 7 on the right. I see 4 here on the left, and I also see 4 on the right. Here I see 13 on the left, which means by rule, this would have to be 13. Remember, that's the equal symbol. So the rule of an equation, you must have the same value on the left as on the right. And to accomplish that, that blank would have to be 13, which means that we would pick answer J. Let's solve one that's a little bit harder. So I'll make my harder face, right? Mary divided 24 rabbit treats equally among her 3 rabbits. John had 56 treats and divided them equally among 8 rabbits. Did the rabbits get the same number of treats? This is a yes or no, but then we'll need to explain. Okay, so let's start with Mary. Mary divided 24 rabbit treats equally among 3. Okay, so on the left, I'm going to put 24 divided by 3. Then on the right, I have John had 56 treats and he divided them among equally among 8. So I have my expression on the left. I'm comparing it to the expression on the right. And my job is to see if it was the same, which means equal. 24 divided by 3, and remember in previous lessons we said that you could use your knowledge of multiplication. 24 divided by 3 would be 8 here on the left. 56 divided by 8 here on the right is not 8, that would be 7. Therefore, that is not equal. So, did the rabbits get the same number of treats? The answer is no. On this side, I think that was John, right? So John's rabbits only got 7, and Mary's rabbits got 8. So to explain, you could keep it simple. You could just say that Mary's rabbits got 8 treats, and John's only got 7 treats. All right, everybody. So again, today's lesson, just in real quick review, our job today was comparing expressions in an equation. We said that expressions are when you have numbers and symbols, but not an equal sign. So for example, 5 plus 5 is an expression, and this is an expression as well. Equation is when you have an equal symbol, which we just showed. Oh my, I'll find that here. Here's some examples of equations is when whatever is on the left side is equal to what is on the right side. And for today's lessons, we had two outcomes. You could be equal using the equal symbol or not equal using the not equal symbol. All right, thanks everybody. I hope this was helpful. We'll see you next time.